Okay, the next piece of abstract nonsense we're going to look at is complete lattices. So lattices are generalization of sets, if you like, and we could indeed proceed without even mentioning lattices, but most treatments of fixed points are based on this kind of abstract setting with lattices. So we're going to do the same because we're not in a hurry. We have to fill 1 hour and a half of contents, and we have to get used to reasoning abstractly about mathematical contents, even in computer science, right? Because what we're looking at is really more computer science-y than mathematics-y. Oh my gosh, I should not start thinking those adjectives. So what we have is generalization of sets, and especially the subset or equal operator and the intersection operator. Well, no, sorry, not the intersection. This is not intersection. This is the big intersection operator, which is a unary operator that returns an infimum. So we'll see in a moment. Or complete lattices will consist of a partial order. You see, and this is less than or equal, but it generalizes the concept of a subset. And you have an operator called inf, which is the infimum. And infimum is it's not quite the same as a minimum. You can, I mean, it helps as a first approximation. Think of it as the minimum of a set. But it has a very specific meaning in terms of this less than or equal operator. And it's also defined for empty sets and for infinite sets and so on. So what it says here is, well, first of all, the infimum has to be a lower bound, right? So the infimum has to be lower than equal any element of A, right? The infimum of A has to be less than or equal any element of A. But it's not just some arbitrary lower bound, it has to be the greatest lower bound. So we have to also have that it's bigger than B for all B that is a lower bound, right? And a very important point here is that the infimum of a set A is not necessarily an element of A, and in fact, A could be the empty set even, right? And if it's the empty set, then you have to be able to return some standard value, you know, some infinitely big value typically is what you need then. So set of alpha is an instance with you know, with these operators. You have prop is also an instance where for all is used to define the infimum. Extended nats with infinity are an infimum. Was I saying the wrong thing all along? Are a complete lattice. Sorry. And the infimum is going to be, of the empty set, is going to be infinity, right? Because you have lots of lower bounds and it has to be the greatest one. So if you say it's 200, then you're like, no, 201 is also a lower bound, and so on. So you have to have a value like infinity. The extended reals, which are defined like this, and I think you don't need that part here, the minus infinity, but extended reals typically have both. And you also have for functions that if alpha is a complete lattice, then the whole thing here is a complete lattice. And you have for products, you also have the same kind of feature, right? And here's a concrete example. Suppose a set with 4 elements, y, a, b, and z. And the idea is y is the smallest element, that's why it's at the bottom, and z is the greatest element. So we call that y bottom and z top very often with lattices. And we can even write, you know, this would be bot, and this would be top. Sorry, I cannot spell top. Can you believe this? There's top. But they're called y and z. It looks a bit like a Super Nintendo controller, the buttons or something, if you ask me. And then we ask various questions, and usually you have students answering them, but now I will pretend I'm a student So you might think I look old and everything, but in my own mind, I look like I'm 20 years old and I'm still a student. So please don't destroy this illusion, at least not while I'm trying to answer these questions, right? So what is the infimum of the empty set? Well, you remember I just said that for extended knots, it would be infinity. So we have to go to the very top of the lattice and we say, well, it's Z. And by the way, I'm not a mathematician and I'm not very good at this stuff. So if there's, I'm hoping I'm getting it right. But if you have any suspicion that there's an answer here I'm giving that is wrong, please take it up at the Q&A, and hopefully I can ask experts if I've done or said anything stupid. So don't take any of what I'm saying here, as the gold standard. And in exchange, I promise not to query you too much about finite examples of concrete lattices at the exam. Okay, so what's the infimum of Z? Well, it's going to be Z itself. You're in some sense you're taking the minimum of that set, right? Remember, so we're going to put Z here, and then A and B. Well, they're incomparable, right? So you go down and you say we're going to have to take Y, right? Because Y is a lower bound. It's below A. It's below B, and it's it's the least common ancestor if you want, or common denominator. So here we go. Y, then Z and A, you go straight to A, right? Because it's the lower bound of both. So that is, oh, sorry, I did the wrong thing. For A and B is Y here. And for the whole thing, then you have to go to bottom. You have to go to the bottom element. That's where everything converges. And then you see some non-examples. So I mean, these are not concrete. These are not, sorry, complete lattices. With the notions of standard notions of subset and the infimum operator. And the problem is that you cannot define the infimum of the empty set. You don't have like a big enough element that that rules over all the others. And here's another counterexamples, which is a bit mind-boggling. I'll let you look at it in the piece of your home. Now, finally, we come to the lean concepts. So complete lattice is going to be a type class, which extends partial order with an infimum. And the infimum satisfies two properties, which are listed here. And then here we register the first instance of complete lattices, and actually the only one we care about, which is the set instance. We're saying that set of alpha for any alpha is a complete lattice. And as LE, we use the less or equal, the subset or equal, non-trick subset. And with operators, you can put them in parentheses like this to so that they become prefix operators. So this is an infix operator. It expects arguments on both sides, and this neutralizes the parsing in some way. And now we can use it just like any other function. And yeah, the properties are very easy. You need a set extensionality in one place here, lots of tautologies, and here you have the definition of infimum. Okay.